Hi, I'm Kendrick Tan and I'm a Year 3 student studying for my Diploma in Electronic and Electrical Engineering. For my internship, I'll be attached to seminar at the Chai Chi plant from 14th of September 2020 to 10th February 2021. Seminar is an electronic manufacturing services company that mainly tests, designs, manufactures, and provide repairs of electronic components for original equipment manufacturers. There are two seminar plants in Singapore, the Penjuru plant and the Chai Chi plant. The Penjuru plant fabricates PCBs, while the Chai Chi plant undertakes PCB assembly as well as end product assembly and packaging. Some of the customer products being assembled are Abbott Laboratories, Hewlett Packard Enterprise, and Aruba Networks, to name a few. The plant has 3 manufacturing levels: Level 2, Level 3, and Level 4. PCBs are assembled at Level 3 using surface mount technology mounters. SMT means that the tiny electrical components like resistors and capacitors are directly mounted onto the surface of the PCB. Once the PCB assembly is completed, it goes through quality checks as well as functional testing before moving to level 2 or level 4 for end product assembly. During these 22 weeks of seminar, I worked with my mentor and supervisor under the Manufacturing Engineering Automation Department. This means that my tasks were to maintain and troubleshoot automation systems around the plant. Other tasks assigned to me were designing, modeling, and 3D printing jigs, fixtures, and other models for use at the production line or display at the automation room, also known as the learning room. For my CDIO project, I had to implement new automation systems and improve on the previous ones using autonomous intelligent vehicles, also known as AIVs. The AIVs being used is the MIR200 for mobile industrial robots. One of the projects that I completed was to improve the automation in the HPE assembly line that the previous interns created. For the conceive stage, I have to research and plan the project. Previously, materials are loaded onto the trolleys. Then, the AIV hooks and tows the trolley to the operator station when called. The other empty trolley is then pulled away. However, using the towing method in that area is disadvantageous because there are tight corners that the AIV has trouble turning around, and empty trolleys have to be manually pulled out before the AIV can hook onto it because it has really tight spacing. Instead, latching onto the trolleys would work better. Latching has a very tight turning radius, and it can also latch onto trolleys in tight spaces and then pull them out. To begin making trolleys that work with latching, the trolley's base had to be built to specifications and requirements, such as the height and the area for the AIV to latch onto. In order to save costs, the existing trolleys were modified by designing a new arrangement for its aluminum profiles. Once the trolleys have been built, they were tested with the AIV. Then, the AIV's program could be made. Testing the program was done repeatedly, and minor adjustments were made each time until the program began to run smoother and faster and with less problems and errors. Once the system was deployed for use in production, further monitoring is done and feedback from the operators and workers are taken to help further improve the system. After implementing the new AIV system, the material delivery is much smoother and quicker compared to the previous towing system, which would always get stuck. I learned a lot about working in an office environment as well as how to communicate with other workers and develop projects. I would like to thank my mentors and supervisors who were very supportive and who gave much needed guidance. Thank you for watching.